L.8.6. We still have the same learning goal. I can solve a quadratic equation by factoring. The difference today is that a is not going to equal 1. Okay? So when a does not equal 1, we're still going to, do the same steps. We're still going to get our equation set equal to what? 0. We're going to replace the y with 0, or if there isn't a y in it, we're going to make sure that everything is all on the same side, set equal to 0. Okay? And then it says factor to what's our purpose for factoring it? What are we doing when we actually factor it? We're renaming it. To rename it. That's what we were doing when a was equal to 1 also. Rename the quadratic expression, that polynomial, rename it so that then you can use the zero product property to solve. Okay? So getting it in factored form, getting it renamed, helps us be able to say, well, now I can set each of the factors equal to 0, solve each of them independently, and see what my solution or solutions are. Now I'm going to suggest highly, it just makes life usually a little bit easier. When you're rearranging these equations to get 0 by itself on one side, I suggest that you try to get the a to be positive. Okay? It just actually makes it a little easier in the factoring by grouping. So instead of moving the negative 4x and the plus 1 over to the left side of this one so that it can be set equal to 0 on the right side, let's rearrange it so that the 0 ends up on the left side instead. So what do we have to do to both sides so that we can deal with the positive a value? What would we have to do? Help me. Talk to me. I want 0 on this side. What should I do? Add 3x squared. So now I have 0 up on that left side, and now I'm going to write it in standard form, and I'm putting adding that 3x squared to that side. So we'll start with the 3x squared, and then we will have plus a negative 4x, and then we'll have plus 1. And now we can identify our a, b, and c and go to work on our diamond, starting to rename it. So our a is what class? 3. B is negative 4, C is 1. Okay, what's another little difference between when A is equal to 1 and when A is not equal to 1? What do we have to worry about in our diamond? Multiplying A times C. So remember, we have to do A times C up here. We can't just put the C value like we can when A is 1, because multiplying by 1 is insignificant. So we just worry about the C value then, and then we still put our B value down here, don't we? So what is A times C in this one? 3. And what's our B value? Negative 4. Okay, what are those factors of 3 that add up to negative 4? Negative 3 and negative 1, okay? Okay, so now we should be able to rename our quadratic so that we can go to work factoring by grouping. So what's the new name? 0 equals what? What's the new name now for this one? 3x squared plus what? Plus a negative 3x plus what? Negative 1x. Now, notice that I'm using addition because when we're doing factoring by grouping, if you leave it as subtraction and you just stick some parentheses in it, you're going to mess it up. So just use addition. Add the opposite if you need to. And then plus 1, right? Okay. Go ahead. Factor that by grouping. Let's see how well you remember factoring by grouping. You have your notes up to help you from lesson 7.2. And our goal whenever we're factoring by grouping is when you factor each group independent of each other, they each have their own GCF. When you factor them, you better end up with a factor in each of those groups that matches, right? Because that becomes the GCF now of the whole 4-term polynomial. So what's our common factor that they have? What do we turn up with? What's the common factor, the greatest common factor then on this polynomial? What is it? What's the matching one? X plus? X plus negative 1. So 0 equals x plus negative 1, also known as x minus 1, of course. And then that is going to be multiplied times what? 3x plus negative 1 or 3x minus 1. Okay? So apparently I gave room for more lines than I thought we would need more. I'm going to clean it up now. There's our renamed equation. This is one of those times that when we solve this quadratic equation, this would be one of those times when using the graph to find the zeros of the function and to be able to claim what you think are the solutions might be a little bit more challenging. In fact, you're going to have to definitely estimate, because when we set these factors equal to 0, only one of them should come out to a whole number or an integer answer. So we set each factor equal to 0. This is our zero product property part of solving. And we add 1 to both sides on this one. End up with the solution x equals 1. That one might be pretty easy to tell from the graph. That it's crossing the x-axis at 1. It has a 0 of 1. It has a solution of 1. But then there's this one. When we add 1 to both sides, we have that 3 in front of that x, so now we have another step to do. We have to divide both sides by 3. And as we've done all year long, when you end up with something that doesn't divide out nicely, if it doesn't divide out even to a terminating decimal, we do not change it to a decimal name it. We leave it as a fraction. So what's the solution here? X equals 1/3. So how easy would that be to see on a graph? You'd probably think, oh, it looks like it's 1/2. You might say 1/4. You might say 1/3, but all of them would be estimates because you wouldn't be for sure. Well, and especially if on a graph that isn't one of your 5 points that you use to make the graph, and you're drawing, we're not really real great at drawing these parabolas. We would, it might even look like it passes, through +1. But how could it? It already does, right? How close are these zeros to each other?
Pretty darn close.
Pretty darn close. Pretty skinny parabola here, isn't it? Opening what direction?
It's going to open up.
It's going to open up when we make the A positive. But if we would have made the A negative, what would it have done?
It would
Open.
up.
Then it would have opened down. Does that change the solutions then, do you think? Does the direction it opens change where it's going to cross the x-axis? What do you think? No, it shouldn't change where it crosses the x-axis. All it does is it flips it over because of the A value changing from positive and negative or vice versa. Now, when we don't have room on our notes, we'll check the other one on the back side, but we don't have room to check. When you check it, you go back to the beginning and you check it remember how we always check in the original. So when we check this one, we would substitute 1 in for x in both places on both sides. And we would make sure that we get a true statement in the end, something equal to itself. Whether that's 1 equals 1 or -6 equals -6, we need an equality. The ones that are going to be fun to check are the fractions. But we're not going to check them with decimal names, especially when they're like 1/3. So what is, we'd have to put 1/3 in there for x. What is 1/3 squared? 1/9. 1/3 times 1/3. 1 times 1, 3 times 3, 1/9. So, you know what, I'll just do it up here because I think we need to see it because you're not going to, I really do not want you to just let that calculator do all the thinking for you. So when we have negative 3x squared equals negative 4x plus 1, this is going to be a real treat to check with 1/3. Negative 3, there's a squared there, 1/3 squared, negative 4 times 1/3, and then plus 1. Well, we just decided that 1/3 squared is 1/9. Do we have to do that first, or couldn't we just so conveniently instead take negative 3 times 1/3 and get negative 1 and then square that instead? What is negative 1 squared? 1. No, because we need to follow order of operations. And Aaron, in order of operations, what comes first? Multiplication or exponents?
Multiplication.
No. Exponents. Yeah. So 1/3 squared
Oh,
is?
you multiply the exponents.
Yeah.
Yeah,
do
exponents is.
There you go.
Okay. And what's this over here? What's negative 4 times 1/3?
1/3. Negative.
Yeah, well, you know, and so let's just leave it as an improper fraction for right now. What is it? Negative 4/3, right? And this is plus 1. Hey, how about since we're working with thirds all along the way here, how about we rename that 1 as thirds? 3/3, right? Okay. Having fun yet?
No,
Okay. What's negative 3 times 1/9?
that's 1/3.
Negative 3/9, which happens to be negative 1/3, right? Okay. And what's negative 4/3 plus 3/3?
Negative 1/3.
Negative 4 plus 3 is negative 1, and so it's negative 1/3. Does it check? Yeah, it checks out. So we did have the right solution. We could do the 1 really easily here. 1 squared is?
1,
1 times negative 3 is?
negative 3,
Negative 3. 1 times negative 4 is?
4. Negative 4.
Negative 4. Negative 4 plus 1 is?
negative
We get negative 3 on both sides, so it checks out. Okay. So yes, you have to do those check problems today. Anybody have any questions about this solving when A is not equal to 1? Okay, let's go to the back side then. Okay. Remember my suggestion, what was it? Make A positive. Rearrange the equation so A is positive. Okay, go ahead, go to work. You do this one. Like we just did on the front. Remember what I said about that changing subtraction to add the opposite to so that you don't mess up because of that? What are those factors of 36 that add up to negative 12?
Negative 6.
Negative 6 and negative 6? So now is our new factor name x minus 6 times x minus 6?
6.
We have to replace the 2x squared, so we are going to have 0 equals 2x squared plus negative 6x plus negative 6x plus 18. We have to have a 4-term polynomial. We're going to factor by grouping. Come up with a common factor, hopefully, and when we're doing that. And remember, we can factor out positives or we can factor out negatives. We factor according to what's going to create that common factor. John?
I have a question.
Okay.
Could I use GCF?
GCF. You mean in the beginning, factor this one with the GCF first?
Yep.
Sure. So what is the GCF, by the way?
2.
2. So you can factor out a GCF of 2. And then why is that so handy, John?
Well, then you have a lot smaller numbers.
Because then A is equal to what?
And A is equal to 1.
Then A is equal to 1. Yeah. So if you factor out the GCF when you can, doesn't mean every time you can, but in this case, we can factor out a 2, which would then leave us with which trinomial, John? What would the new trinomial be?
0 equals x squared minus 6x plus 9.
Plus negative 6, did you say? Plus 9?
I said minus.
Oh, okay, you said minus. Okay. And then what happened to that 2? Can we just ditch it?
No,
It's
that's
still part of the name, it's out front. Okay, so, but we can, when we're done factoring the x squared minus 6x plus 9, that 2 is still a factor, but we only have to set the factors that have x's in them equal to 0. So in the end, that 2 does kind of become irrelevant, and you should still get the same solution we do by doing factoring by grouping. So yes, John, you can. Okay, so since I end up with x plus negative 3 by using 2x as my GCF for my first group, what do I probably need to make sure that I use for my, instead of 3, or instead of 6, use negative 6, right? Because if we use positive 6, we end up with a negative x. We need a positive x, so we use negative 6, and then we get our common factor, we get that x plus negative 3 that they have in common. So now I can say its name is x plus negative 3 times what? What's the other factor? 2x minus 6. Or I'm going to put plus a negative 6 for a moment because that's what I was doing with the other one. Okay. Clean this up. I really have x take away 3 times 2x take away 6. What do we do with that now?
Set them both equal to 0.
Set them both equal to 0. Okay, what happens when you do that? What do you get? Have you done it yet? Okay,
You get x equals 3.
you get x equals 3 both times?
Yeah.
Get x equals 3 both times. So what does that tell us?
That there's
Only one solution. What else does that tell us?
That's where the vertex is.
That's where the, what do you mean that's where the vertex is? The vertex that is sitting on the x-axis, so it's sitting on the x-axis, and that's why there's only one 0, only one solution. So we end up with, doesn't matter. And I'm going to guess, John, that you ended up with x minus 3 times x minus 3. Am I right?
No, I got the exact same thing that you did.
I thought you were factoring out a 2.
I put 2 times x minus 3 times x minus 3.
That's what I said. Did you have an x minus 3 times an x minus 3?
And then I put it back into one of the things, and I got 2x minus 6 and then x minus 3.
Oh, then you multiplied that 2 times. You didn't have to. Here's what you could have done. You could have just like ditched that 2 and set one of your x minus 3's equal to 0 and solve. Okay? So either way, we get x equals 3, but we don't say there are 2 solutions because it's the same solution. There's only one real solution. Doesn't matter which one you circle. There is only one real solution, and it is x equals 3. Now, I want you to go do a check problem. Check. Because this is what you're going to do on your homework. And where are we going to check it out in? The original equation before we rearranged it and got it set equal to 0. So we are going to check it in our negative 2x squared equals 18 minus 12x form. Substitute it in both places where the x is. Show the work. You don't just say, oh, this equals this in the end. Show how it gets there. Prove that it really does get there. Don't pretend that, it is getting there.
That's a 12.
I don't know, what is it supposed to be?
12.
A 12. Oh, that's, yeah, I probably should put a 12 there then, huh? Okay, so they'll make this a 12 instead of a 2.
Good job.
Good catch. I end up with negative 18 on the left side. I end up with negative 18 on the right side. And I say, good deal, it checks. Okay. So when there's two solutions, you have to do two check problems. When there's one solution, you only have to do one check problem. And we should always get solutions today. We're not at that point yet where we're getting no solutions. We will get to that point, but we're not there yet. We said that is another possibility, didn't we? No real solutions. Okay, so y'all should lose the paper, and using these notes, get to work on the homework.
Yeah.